Hi, hello. My name is Mohammad Nadim from Mechanical Engineering. Subject Thermal Engineering Systems. Title of the topic Ignition and its stages in combustion. Combustion, ignition, the science of its birth. This presentation explores the intricate processes behind combustion ignition from fundamental principles to real world applications. Understanding thermal ignition fundamentals: fuel, heat, oxygen. Fuel, the material that burns, providing the chemical energy from for combustion. Heat, the energy required to initiate and sustain the chemical reaction of combustion. Oxygen, the oxidizer that reacts with fuel, enabling the release of energy. Threshold temperatures and energy requirements. First, each fuel has a specific ignition temperature. The minimum temperature at which it ignites in the presence of air. Ignition also requires a certain amount of energy, often supplied by a spark, flame, or heat source. These parameters are crucial for controlling ignition in engines and industrial processes. Chemical kinematics in ignition processes: activation energy, reaction rates, chain reactions. Activation energy, the energy needed for molecules to overcome their energy barrier and react. Reaction rates, the speed at which chemical reactions proceed, influenced by temperature and reactant concentration. Chain reactions, a series of reactions where products of one reaction act as reactants for the next, accelerating the combustion process. Spark ignition in gasoline and diesel engines. Spark plugs, fuel injection, compression ratio. Spark plugs generate a spark to initiate combustion in gasoline engines and also used in petrol engines. Fuel injection precisely delivers fuel into the combustion chamber. Due to this fuel injection, ignition starts, majorly used in diesel engines. Third, compression ratio increases temperature and pressure, aiding ignition. Spontaneous combustion mechanisms. First, oxidation, heat accumulation. Second, third, ignition. Oxidation, slow exothermic reaction generating heat. Heat accumulation, heat trapped within the material, raising temperature. Ignition, temperature reaches ignition point, leading to rapid combustion. Critical factors affecting ignition delay: temperature, pressure, fuel properties. First, temperature. Higher temperatures accelerate reaction rates, reducing ignition delay. Pressure, increased pressure increases molecular collisions, shortening ignition delay. Fuel properties, chemical composition and volatility influence ignition characteristics. Flame propagation and combustion stability. Flame front, propagation speed, stability. Flame front, the boundary between the burned and unburned gases. Propagation speed, the rate at which the flame front moves through the fuel air mixture. Stability, the ability of the flame to remain stable and not extinguish. Industrial and safety implications of ignition. Engine design, safety standards, fire prevention. Engine design, optimizing ignition, timing and combustion efficiency, preventing accidental fires and explosions in workplaces at safety standards. Fire prevention, implementing measures to minimize fire hazards in various settings. Future trends in combustion technology and research. First, alternative fuels, exploring renewable and sustainable combustion sources. Advanced control, precisely controlling ignition and combustion for optimal performance. Emissions reduction, developing technologies to minimize harmful emissions. Thank you.